Rahim. I am Ms Yasmeen Iftikhar from Multan Public School and College. We are discussing about chapter number 5. The topics are solid state, types of solids. From chapter number 6, we are discussing about the solution and the types of solution. First of all, we discuss about the solid state. The solid states propose only the vibrational motion. We do not see these type of motions. The molecules of the solids vibrate at the same position continuously. Only vibrational motion is present in solids. The properties of solids are, first of all, melting point, the temperature at which the solids start melting and coexist with dynamic equilibrium with liquid state is called melting point. The second property is the rigidity. Rigidity means the strength of solid. Strength of solid. The particles of the solids are not mobile. They have fixed position. Therefore, the solids are rigid in their structure. Next one is the density. The solids are denser than liquid and gases. The solid particles are closely packed and do not have empty spaces between the particles. For example, the density of the aluminium is 2.7, iron is 7.86, and the gold density is 9.3 gram per centimeter cube. So the density of gold is maximum among all these metals. Our next topic is the types of solids. There are two types of solids, amorphous solids and crystalline solids. Amorphous solids, in which the particles are not regularly arranged or their regular shapes are destroyed, are called the amorphous solid. For example, plastic, rubber, glass, etc. And the melting point of these solids is not fixed. They are randomly arranged. The molecules of the amorphous solids are randomly arranged. Our second type is the crystalline solid. The solid in which the particles are arranged in definite three-dimensional pattern are called the crystalline solid. They have sharp melting and boiling point because their structure is fixed. For example, the diamond, crystalline solid is diamond, and the sodium chloride. As you see, the shape of the diamond is different, but chemically they are crystalline solid, and their arrangement in three-dimensional space, the arrangement of the atoms in three-dimensional space is fixed. As you see in the diagram, the plastic has haphazard arrangement of the atoms and molecules, while in cotton and in candies, the haphazard arrangement of the molecules are there. So they do not have a fixed type of a molecules or fixed type of a structure. So these are amorphous solid, but the diamond has fixed crystalline structure. So it is solid and fixed boiling point and melting point. In this figure, you can see that In first figure, the molecules are arranged in three-dimensional structure. The regular arrangement is present, while in the second diagram, the regular arrangement is not present. So the regular arrangement is not present. These are the amorphous solid. And the first diagram, in which the regular arrangement of the molecules are present, these are known as the crystalline solid. Our next topic is the allotropy. Allotropy, the existence of the elements in more than one form in same physical state is called allotropy. Suppose at room temperature, the ozone and the oxygen both are present. Ozone is present in the sky and oxygen is present in our atmosphere. Both are present at the same physical state. So these two forms are known as the allotropic forms of oxygen. Our second example is the sulfurate. Sulfurate it has the crystalline structure, and they are also present in two different forms, in rhombic form and in monoclinic form, at page number 90 in your book. Our next topic is the transition temperature, the temperature at which the allotropes change into another form. One form is changed into another form. That this temperature is known as the transition temperature. For example, S8, sulfur 8, या इसको कहेंगे आप rhombic sulfur at room temperature. It is present as room temperature, but when temperature is increased from room temperature to 96 degrees centigrade, the rhombic sulfur is converted into monoclinic sulfur. That temperature, 96 degree temperature, is known as the transition temperature. In phosphorus, white phosphorus is present at a room temperature. When the temperature is increased up to 250 degrees centigrade, this white phosphorus is converted into red phosphorus. Then this is known as 250 degrees centigrade is the transition temperature. At your book, page number 91, the SN is very poisonous. It is grayish in color and cubic in structure. At 13.2 degrees centigrade, stannic converted into white stannic, which is tetragonal structure. And first one is the very poisonous, and the brittle powder, the red one, phosphorus, is less reactive and non-poisonous, and it is also brittle and in the powder form. First one is the cubic one, which has definite structure, while second one do not have definite structure, so it is a non-poisonous one. Now we start chapter number 6. Solution. A solution is the homogeneous mixture of two or more substances. For example, bronze at page number 97 in solution. Bronze is the example of solution, solid solution, which is also known as an alloy. Zinc and copper is mixed together. It is converted into bronze. Seawater is also the mixture of solution, liquid solution. The first example of this solution, or the first type of this solution, is the aqueous solution. A solution which is formed by the dissolving of a substance in water is called an aqueous solution. All those solutions which dissolved in water or which formed in water, and the water is present in very higher quantity or greater quantity, then this type of a solution is known as an aqueous solution. Next one is the solute. The component of the solution which is present in smaller quantity, it is called solute. All those substances which are present in smaller quantity in the solvent, then it is known as the solute. Suppose table salt when add into a pinch of table salt when add into the water, then this pinch of table salt is known as a solute. Next one is the solvent. The component of the solution which is present in larger quantity, it is called solvent. In water and salt example, the water is the solvent. The next type of solution is the saturated solution. A solution containing maximum amount of solute at a given temperature is called saturated solution. Suppose at a room temperature, when we add a spoon of salt into the water and would add again and again, salt is added into the water at a particular time, no salt is added into the water, then this type of a solution is known as a saturated solution. The example of saturated solution is a soda. A soda is a saturated solution of carbon dioxide in water. That's why when the pressure is released, carbon dioxide gas formed in the form of a bubble. It is removed. If we add some chocolate powder into the milk, after taking some time, the chocolate powder is stopped dissolving into the milk. This type of solution is known as a saturated solution. Unsaturated solution, the solution which contain lesser amount of solute than that of the required to the saturated, it is at that temperature, at a given temperature, it is unsaturated solution. Next one is the supersaturated solution. Supersaturated solution is that type of a solution that more concentrated, it is more concentrated than the saturated solution. We get a saturated, so we have a saturated solution. When we increase the temperature of that saturated solution, we can add more and more amount of solute into the solvent or into the solution, into the saturated solution. At a particular temperature, more solute do not dissolve. The solute do not dissolve at that temperature. That type of a solution is known as a saturated solution at that temperature, at a particular temperature when we increase it. Next one is the dilute solution. Dilute solution is the solution or those type of a solution which contain a relatively smaller amount of dilute solute into the solution. It is very light and minor type of a solution in which this amount of solute is very low or very less. In other words, the concentrated solution are those type of a solution which contain larger amount of solute than that of the solvent. If the solute amount is smaller, then it is known as a dilute solution. If the solute amount of solvent, if the amount of solute is larger as compared to the dilute solution, then it is known as a concentrated solution. Our last topic is the type of solution. There are different type of a solution. First one is the solution of gas with gas. If gas is gas with mix, suppose air. Air is the mixture of different type of gases, or the mixture of hydrogen and helium, which we add into the weather balloon, or the mixture of nitrogen and oxygen in the cylinder of respiration. The second type is the gas in liquid. Gas in liquid, oxygen in water or carbon dioxide in water are the examples of gas in liquid. The third type of solution is the gas in solid. hydrogen absorbed on palladium, then this is known as the example of the gas in solid. Liquid and gas, for example, must, fog, liquid air, pollutants. Next one, the fifth type of the solution is the liquid in liquid. For example, alcohol in water or benzene and toluene. Next type is the liquid and solid. The example of liquid and solid is the butter and cheese. Next one is the solid gas, solid and gas. Dust particles and smoke in air are the examples of the solid in gas. Eighth type is the solid in liquid. For example, sugar in water. Last type of the solution is solid in solid. For example, different types of alloys, bronze and opal. These are the examples of the solid in solid. For example, is copper and nickel coins are also the example of solid in solid. Thanks students. Today's lecture is completed. Thank you very much.